Hello there, Mr. Sutton here, bringing you the Algebra 2 10-4 homework solutions on graphing sine and cosine. On this problem, they want us to identify the amplitude and period and then graph this function here. So for the amplitude, that's going to be this 3 out in front of the function. For the period, we're going to have 2 pi divided by the b value. Now we have an invisible b value of 1 right here. So 2 pi over 1 gives us 2 pi. And now to graph this thing, let's come up with what the transformation is. Then we'll do the parent table, transform that, and then we'll graph it. So for the transformation, this 3 out in front is giving us a vertical stretch, because it's bigger than 1 and it's outside. So let's go ahead and do the parent table now for sine. That's 0, 0, pi over 2, comma 1, pi 0, and all the rest of these. So for the g function, to modify this, we're only doing things vertically. We're not doing anything inside the function. So x is just going to be x. But for the y values, we need to do 3 times those. So I'll keep all my x values the same. 0, pi over 2, pi, 3 pi over 2, and 2 pi. For the y values, I'm just multiplying by 3. So I've got 0, 3, 0, negative 3, and 0. Graphing all that out, I've got the point 0, 0 right here, and then we have pi over 2 comma 3 up here, then pi comma 0, 3 pi over 2 comma negative 3 is down here, and 2 pi comma 0 is here, and this gives us 1 period of this sine function. On this problem, we want the amplitude and period of this function, and then we're going to graph it. So for the amplitude, that's this 1/2 out in front. The period is going to be 2 pi over the b value 4 pi. So 2 pi over 4 pi gives us a period of 1/2. So that's how long a cycle of this will be. And now for the transformations happening, the 1/2 outside is giving us a vertical shrink. The 4 pi inside, since it's bigger than 1 and it's inside, is giving us a horizontal shrink as well. So vertical and horizontal shrink. Here is the parent table for cosine. We've got 0, comma 1, pi over 2, comma 0, and the rest of those. So for my transformed version of this, for the x values, we are doing a horizontal shrink. So I'm going to have to multiply here by 1 over 4 pi. It's opposite of what it looks like. For the vertical shrink, I just need to do 1/2 times the y values. Let's go ahead and apply all those now. So 0 times 1/4 pi, or 1 over 4 pi is 0. And then we have pi over 2 times 1 over 4 pi. The pi's are going to cancel. We have just really 4 and 2 in the denominator, so that's going to be 1/8. And now pi over 4 pi is going to give us 1/4. This will be 3 over 8. And then for this last one, 2 pi over 4 pi gives us 1/2. Just like it did up there. Next up, we're doing 1/2 times all the y values. So 1 becomes 1/2. 0 is still 0. Negative 1 is negative 1/2. 0 is 0. And 1 is 1/2 again. Graphing all this out, my vertical grid lines need to go by probably halves would be good, or something even smaller. And then for the horizontal grid lines, I at least need to go by eighths or something that I could easily pick those out if I were to take half of it. So let's see what I did here. So yeah, vertical grid lines going by 0.5s. Horizontally, 0.125 is the same as 1/8. So let's graph out my points. We've got 0, comma 1/2, 1/8, comma 0, 1/4, comma negative 1/2, and now we've got 3/8, comma 0, and finally 1/2, comma 1/2. And here is our first period of the cosine curve. To graph this function, let's first identify the transformations. The 2 out here is giving me a vertical stretch. The -1, which is also outside the cosine function, is giving me a vertical shift. It's going to be what it looks like, so down 1. So vertical stretch and a translation down 1. Here is our cosine parent table again. 0, 1, and all the rest of those. And now for the g function, let's modify the x and the y rules. For x, there's nothing actually happening horizontally, so we'll just leave that the same way that it is. For y, we are multiplying by the 2 and then subtracting 1. So I'll write 2y minus 1 for that. So for the x's, I'll just keep my original x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. For the y values, I'm going to multiply by 2 and subtract 1. So we have 2 minus 1, which is 1, and this will be 0 minus 1, which is negative 1. Next up, this will be negative 2 minus 1, which is negative 3. And then we have 0 minus 1 is negative 1, and 2 minus 1 is 1. So I can make my horizontal grid lines go by pi over 2's. My verticals, I'm going to go by probably 1's would make sense here. So my first point is 0, comma 1, which is right here. Next up, we have pi over 2, comma negative 1, and pi, comma negative 3. And then we do 3 pi, comma negative 1, coming back to that vertical middle of it there. And 2 pi, comma 1 is up here. And here is my cosine curve. For this problem, we're trying to graph this transformation of the sine function. Let's first figure out what the transformation involves. This 1/2 here is giving us a horizontal stretch. The plus 2 pi inside the function is actually shifting us left 2 pi, and the plus 3 outside the function is shifting us up 3. So we have a horizontal stretch and a translation of left 2 and up 3. Alright, let me do my parent table for the sine function. So that's 0, 0, pi over 2, comma 1, and the rest of those. And for my g function, I need to change my x and y rules to accommodate this. So horizontally, we're going to have to multiply by the reciprocal of this, so by 2, and then we have to subtract 2 pi, and we have to go reverse PEMDAS, so the outside stuff actually happens to x first, followed by this inner stuff. So I'm going to write 2x minus 2 pi. For the y values, I just have to add 3 to all of those, so y plus 3. Let's do the x values now, all at a time here. So we have 2 times 0 minus 2 pi is negative 2 pi. And then 2 times pi over 2 is pi. Pi minus 2 pi is negative pi. Then we have 2 times pi minus 2 pi, which is 0. And the pattern continues here. We have 3 pi minus 2 pi is 1 pi. And 4 pi minus 2 pi is 2 pi. Next up, let's add 3 to all the y values. So 0 becomes 3, 1 becomes 4, then we have 3, positive 2, and then positive 3 again. So I'll just make my horizontal grid lines go by maybe pi's would be enough, and then 1's for the verticals. So our first point that we'll graph is negative 2, comma 3, which is up here. Then we have negative pi, comma 4, right up there. 0, comma 3, pi, comma 2, and 2 pi, comma 3. And we'll just graph this one period of this sine function. We're going to graph this transformation of the cosine function. Let's first identify the exact transformation happening. The negative outside gives us a vertical reflection. The minus 2 outside is a shift of down 2, translation down 2. And then the plus pi inside gives us a translation of pi to the left, opposite of what it looks like. So we have a vertical reflection and translating left pi down 2. So here is our cosine parent table. We've got 0, 1, and the rest of all those. Next up, we do the g function. So for the x values on this one, all we're doing horizontally is going left by pi, so we'll do x minus pi for that. Vertically, we have to reflect and then go down 2, so this will be negative y minus 2. For the x's, let's modify all those. So 0 becomes negative pi. Pi over 2 minus pi is negative pi over 2. Pi minus pi is 0. 3 pi over 2 minus pi, that'll be pi over 2. And 2 pi minus pi is 1 pi. Now we're going to negate the y and subtract 2. So this will be negative 1 minus 2, so negative 3. This is 0 minus 2, so negative 2. This is positive 1 minus 2, so that'll be negative 1. And then we have negative 2 again and negative 3 again. All right, so graphing these out, let me just make my grid lines go by pi over 2's to get these, and by my y values by 1's. So we've got negative pi right here and negative 3, so that's our first point. Negative pi over 2, negative 2 is right here. 0, negative 1 is there. Pi over 2, negative 2 is right there. And we have pi comma negative 3 right down there. And then we'll just graph this cosine curve. Just one period. For this one, we're going to transform this cosine function. So to start that process, let's identify the transformations happening. The negative 4 outside here is doing two things. The negative piece of this multiplying is going to give us a vertical reflection. The 4 gives us a vertical stretch. And then the plus pi over 4 in here is a translation of left pi over 4. The minus 1 outside is giving us a translation of down 1. So just to summarize all that, we have a vertical stretch and reflection. We have a translation of left pi over 4 and down 1. So let's do our cosine parent table. That's 0, 1, and all the rest of those. And then for the g function, for the x values, the only thing going on horizontally is this left pi over 4. So we'll just do x minus pi over 4. And then vertically, there's a few things going on. So we have a negative 4 times the y values, and then we're going to follow that with a minus 1. So negative 4y minus 1. Let's do the x's now. So we have 0 minus pi over 4, or negative pi over 4. Pi over 2 minus pi over 4 is pi over 4. Pi minus pi over 4, that's like 4 pi over 4. So that'll become 3 pi over 4. And next, 3 pi over 2, that's really like having 6 pi over 4. Subtracting pi over 4 from that gives us 5 pi over 4. And then 2 pi is kind of like 8 pi over 4, so this will be 7 pi over 4. Now for the y's, we're going to multiply by negative 4 and subtract 1. So this becomes negative 4 minus 1, which is negative 5. We have 0 minus 1, which is negative 1. This becomes 4 minus 1, so 3. 0 minus 1 is negative 1, and this again becomes negative 5. So graphing all that out, I'm going to go by, I think pi over 4's works for the horizontal scale. Vertically, if I do just 1's, as long as I can get down to negative 5 and up to 3, I should be good on this. So our first point was negative pi over 4 comma negative 5 down here. Next we had pi over 4 comma negative 1. 3 pi over 4 comma 3, 5 pi over 4 comma negative 1, and finally 7 pi over 4 comma negative 5. And then let's graph that nice cosine curve.